before summarizing, I will just take one small example, then you tell me how do you answer it. Assume there are two lines, line 1 here, line 2 is something like this in the first quadrant. Line 1 in the question it is given less than or equal to, line 2 greater than or equal to. Need not be a parallel line, at one point they may intersect, it is okay. Now in this case, how do you consider the feasible region? Line 1 here less than means this side. Line 2 here greater than means this side. Students, what is the common region? Common region may come somewhere later, but not in the first quadrant. In the first quadrant, this is less than, this is greater than, it results into no feasible region at all. You do not get a common region at all in the first quadrant. You have to conclude there is no solution. Why it is no solution? Always optimum solution lies in the feasible region. If a graph does not have a feasible region, you have to conclude there is no solution to the given LPP. Alright. Now students, now we will quickly summarize what all I have discussed in the earlier parts. First one, we discussed LPP, meaning we considered. It will come as a problem which deals with optimizing the available resources. But when you solve, you are going to solve linear constraints. It is called linear programming problem. It has parts. There are 3 parts to an LPP. One is objective function, structural constraint, non-negativity constraint. Now, LPP problem point of view, 2 kinds of problem you face. Formulate LPP. They will give you a nice story, interesting story. With the help of that, you have to formulate means you have to write for that particular question what is objective function, what is structural constraint, what is non-negativity constraint. In case of structural constraint, different ways they said, you have to read the words at least, at most, exactly, least number, highest one, then accordingly greater than, less than type symbol will come. Then formulation is the third one. Then about solving an LPP. How do you solve an LPP? 2 methods, graphical and simplex. Syllabus is concerned, it is only the graphical method explained. So, graphical method of solving an LPP. What are the steps? Inequalities, you take equality, draw the lines with the corner points, shade the feasible region. 1 mark theory question, what is feasible region? Region in the graph which satisfies all the constraints, satisfies structural constraints, non-negativity, which area it satisfies, that is called feasible region, or the solution points involved in that we call feasible solution. Alright, it has 3, less than, greater than. Whenever it is less than, shade towards origin, towards 0. Whereas the other one, it is against 0, not towards 0. You have to shade opposite 0. So, one is towards origin, other one is against origin. Then, we have considered any new corner points if you get, find that by solving. If you find out exactly you may get, if there are decimal comes you may be in little trouble, you have to solve it. Students, after finding out that, you have to find out, substitute all the corner points of feasible region in Z. Only the corner points of feasible region, not all the points. When you substitute, we may get 1 solution, or we may get 2 solution, or we may get multiple solution. Therefore, LPP may have 1 called unique solution, 2 solutions, multiple solution. Can LPP may have no solution? Definitely yes. If it is the case, no common region, there is no solution. Can LPP may have unbounded solution? If at all it is, listen, look at this example, line 1, line 2, both are greater than, less than means towards origin, greater than means like this. Common area comes, then it is unbounded, provided, clearly you make a note, provided it is a Z max. If it is a maximum one, no doubt shading is same whether it is maximum or minimum. If it is a maximum one, maximum goes at infinite value. As it x increases, y increases, you cannot find the boundaries to it. It is unbounded solution. If at all you say, if it is same unbounded one, but if it is a question z minimum, your answer cannot be unbounded. Minimum value lies at the initial points, substitute that and you will conclude. With this, we will conclude this chapter, linear programming problem, very important and interesting. As you proceed in the higher studies, this chapter again you learn. Thank you very much for patient listening of the chapter, linear programming problem. Thank you.